These questions, they're not bad once you set them up. They don't all have nice answers. Some of them do, some of them don't. But they are a little bit tricky kind of initially to set them up. Once you have them set up though, it's very, very quick to do the problem. You might have to manipulate the graph on Desmos a little bit with your fingers on your touch screen, but once you set this up, it's not bad to do. This very first question is probably the worst one we're gonna do for the whole day. So this says an airline has the following carry-on luggage requirements. And it says the length of the carry-on must be 10 inches longer than the width. The sum of the length, width, and height must be, pretend that just cross out that less than for me. Let's just say it equals 40. And, because I don't want to deal with an inequality, that was not the intention of the question. And it says, what's the maximum possible volume? Okay, if you guys see like a maximum or minimum, if you remember what we were doing right before Thanksgiving break, we were looking at relative maximum and minimum. So this is going to be related, if it asks you for a maximum, to a relative maximum on the graph. Okay, so we're going to try and translate this into an equation, and it's going to be a little bit of a geometry throwback here. All right, so you guys, unless it says otherwise, you go ahead and assume that like the carry-on luggage bag is going to be like a rectangular prism, like from geometry. Okay, so we're going to do volume is length times width times height, just in general. All right, so it says, I'm going to try and write some expressions here. So it says the length is 10 inches longer than the width. So if I just let like L be the length, W be the width, and H be the height, what would you write if I say that the length is 10 more than the width? Like, how would I write that? The length is 10 more than the width. Like, how could I write that as expression? It says L plus 10. Not quite. If I just want to do like, you're totally on the right track. Just 10 more than the width. Like, how would you write that? Just W plus 10. So 10 more would just be 10 plus, not 10 times. So just be careful with that. So 10 plus the width, okay? I'm going to try and write each of these so we're just using one variable when I plug it into the equation. Okay, so the width, we'll just call that W. All right, and then the only other information they tell us in the directions here, it says the sum of the length, width, and height has to be, we crossed out that less than 40 inches. Okay, so sum hopefully means to you guys adding, right? So the length plus the width plus the height has to be 40. Okay, now this is super tricky. So what I want to do is I'm going to go ahead and take what I have for the length, that W plus 10, and I'm going to substitute that in for the length in that sum formula real quick. And we're going to do two steps with this in a second here, if I can find my marker. All right, so I'm going to write W plus 10 plus the width plus the height has to be 40. And I'm just going to combine some like terms here real quick. So I'd have 2W plus 10 plus the height has to be equal to 40. And maybe I could simplify that just a teeny bit more and move the 10 to the other side. So I'm going to say 2 times the width plus the height, if I subtract that 10, has to be equal to 30. All right, now here's the goal. I want to try and write this volume information with just two variables, just volume and then one other variable, not all three of those, so we can make an equation out of this. What I can do, just right here, I'm going to substitute that W plus 10 in for the length. Now, I know it doesn't really look like it, but if I just do one step right here and subtract, sorry, I wrote too big. If I just subtract the 2W, just really quick there in that equation, I was using the sum formula, I can have the height would be 30 minus 2W. I can also have the height using the width as the variable. So then all three, length, width, and height, are written in terms of the width. So it's kind of tricky there, but that's what I'm trying to accomplish. So then I can plug those in. So in for the height, I'm going to put that 30 minus 2w up there too. Okay, so my volume, the length, I'm just going to put parentheses around this. You don't have to, but I'm going to. So w plus 10. The width, I'm just going to call w. And then the height, I'm going to put parentheses around this, 30 minus 2w. So then my whole volume formula is all in terms of the width. Just having two variables here, this is what's going to allow you to graph this. And you don't have to multiply it out or anything. We can literally just type it in with parentheses, and we're going to use Desmos to do this. Okay, now the one little annoying thing, all right? You just got to use x and y. Desmos doesn't like other variables. So just going to change this up to be an x and a y instead of a volume and a width. So you don't have to multiply it out or anything. I just wrote a w when I was supposed to write an x. Just substituting in x for every w and y for the volume, because the Desmos won't like it if we try to use different letters. All right, so this is where I'm going to pull up my Desmos. So if you guys got your laptop out, just go ahead and I'm going to pull this to the side, see if I can get it on the screen so you can see the equation here. Now, we might have to manipulate this a little bit, but just use the little parentheses. So I'm going to write y equals, and you can really put these in any order. I put the x plus 10, then I had the x, and then I had 30 minus 2x. And you can maybe see on my screen, you can't see the graph really well, but I'm just going to use my fingers to kind of manipulate that a little bit. And I know it can be kind of tricky, but just kind of play around with it. It usually takes me a minute or two to kind of get it where I want it. And I'm just going to move this out of the way so you guys can see the graph maybe a little bit better. And I just grab the y-axis just up and down with my fingers, and then x-axis left and right, and you can mess around with it until you get a decent picture. You want to maximize the volume. Okay, so there's a bunch of points on here. We could look at the zeros, but that's not going to help us do anything for this question. What you want to look at, I'm just clicking on these critical points so you can see them on the graph. What you are looking for is to maximize the volume of this. So you want to look for the relative maximum, which is just going to be like the top of the curve here. You don't want to have, in this case, your x-coordinate is going to represent your width. So we don't want to look at this point because that would give us a negative width. So this is the point we want right here. And some of these have nice answers and some of them don't. This one does not. In this case, x, which is really the width, is going to be that 931. And this is supposed to be in inches. So I'm just going to go ahead and write all the decimal places that Desmos gives me there. So the width is like the x-coordinate of that point, right? And then the actual volume, what the volume would be, is just the y-coordinate of the point. So y in our equation, but volume for what we're talking about is going to be that 2052.205. And anytime you do volume, just as a little throwback from geometry, that's in whatever your dimensions are, cubed. So the volume of this carry-on luggage would be 2052.205 inches cubed. So that's a big bag. Is anybody having a question? The hardest part is setting it up. Once you set it up, you're just looking for the top of that little curve there.
How did you do that?
So you just I just grab and stretch. If anybody needs help, sometimes this takes me a second to do it. So just kind of stretch it around. So the easiest way I can tell you to move it is literally just squeeze the x-axis or the y-axis with your fingers, and you can kind of mess around with it a little bit. So it doesn't have to be a perfect picture. I'm just really trying to locate that relative maximum is what I'm trying to do. If you need help, I'll come help you with it, because I know it takes me a minute sometimes to get it to move. Sometimes it's a little bit tricky. So if you need help, just let me know. I'll be happy to help you with that. Is anybody having a question? Okay, now I have a super similar problem, but a little bit different underneath here. And again, we're just going to go ahead and assume this is talking about a digital camera. It's going to assume that this is a rectangular prism unless it tells you otherwise. So you can just use volume is length times width times height again here. 2. And this says the design for the digital camera maximizes the volume while keeping the sum of the dimensions at 6. The length must be 1.5 times the height. What should each dimension be? Okay, so ultimately when I do this question, I need to tell like the length, the width, and the height. Forgive, I should have put like a little answer blank just to make sure we answer that question. But we're going to say what all the dimensions are going to be. We're only going to get one dimension off the graph, but then we should be able to apply that to figure out the others. Okay, so it says digital design for the camera maximizes the volume. The sum of the dimensions is 6. So one equation I could write for this, we could just do like the length plus the width plus the height is supposed to be 6 inches. So I'm just going to write length plus width plus height equals 6. And the other thing it tells us is the length is 1.5 times the height. So how would you write 1.5 times the height? Like how could I change that into an expression? What would that look like? Here we go. Exactly, just 1.5 each. All right, now, those are the only 2 things I have to work with. I'm going to try to get all 3, length, width, and height in terms of what variable do you think here? H, exactly. So this is in terms of the height. So we're going to try and get all of them in terms of the height. Now, what we're going to do, I'm going to start out and I'm just going to sub this in for the length right there. So that equation would become, bless you, 1.5 times your height plus your width plus your height equals 6. Okay, now let me ask you, if I combine like terms here, I have 1.5 h and I have another h over here. How many h's, if I added those together, would that be? 2.5, right? This is just 1 plus 1.5. So we'd have 2.5 times the height plus the width is going to be equal to 6. Now, I already have the height in terms of the height because it's just h. I have the length in terms of the height, and all you have to do to get the width in terms of the height, I'm just going to subtract this 2.5 h. So trying to get the width by itself, and when I do that, then I've got the width and the length both in terms of the height, and we can just call the height h. All right, now we're going to just sub this into this lovely little volume formula. So my volume, my length is 1.5 times the height. My width is 6 minus 2.5 times the height. And then my height, I'm just going to put h for the height. And again, I know this is a little bit tricky, but when I actually plug this in to Desmos, I just have to use x and y. So wherever the volume's at, that's where I'm going to put y, and h, I'm just going to replace that with an x. So I'm going to slide this to the side here real quick. And again, you don't have to multiply it out. You can just type it right into Desmos, right like that, and it'll do it for you. So just whenever you're doing your graph, we're just going to make sure we use y and x instead of volume and height. So I'm just going to do 1.5, but put an x next to it. And then I'm going to go ahead and put in parentheses 6 minus 2.5. Just use x instead of h. And then for the h, again, on the end, I'm going to use x. So I'm just typing that in. Everywhere I see a y, or a volume, I'm going to replace that with y. Everywhere I see a height, just replace the height with an x. So it'll graph it for you. And then again, this one is really, I'm just kind of stretching my y-axis. I'm just going like up and down with my fingers. Just kind of manipulate. Just try to grab an x or y-axis. That's the easiest way to move it around. And again, we're trying to maximize this volume. So you want to look for relative maximum. And if if you just click on the graph, it should go right to that point. And the way that's laid out on the graph, your height is going to be where your x coordinate is, and your volume is going to be where your y coordinate is. So we're only going to get one dimension here, right? We're going to get the height, which is just the x coordinate of that point, so 1.6. So I'm just going to plug that in, and this is in inches. All you have to do to find the length and the width, so the length is 1.5 times that. So I'm sorry, I'm just doing this on my calculator real quick, but 1.5 times that, and that doesn't show up very well today, so I'm not gonna put that there. This should be 2.4. The width is 6 minus 2.5 times the height, which is the 1.6. So I'm just plugging it into those two little formulas there. And then this would be 2 inches. And if you want to check that real quick, you could multiply that back out, and that volume should be that 7.68. I know they don't ask you, I'm just going to write it down on my paper so I have it, but the volume would be 7.68 cubic inches for that digital camera. Is anybody having a question? All right, those two are super similar. They're maximizing. And the last question is not really maximum or minimum, but it's just going to ask you to basically use the polynomial to find the dimensions of a container in this case. So this is just a hair different, and I'm going to show you 2 ways to do this. Okay, so it says the height of a pod's moving container is 4 feet less than the width. All right, so I'm just going to write my height is 4 feet less than the width, so I'm just going to say width minus 4. Okay, it says the length is 9 feet longer than the width, so if I'm 9 feet longer, I'm going to add 9. Less than we're going to subtract, more than we're going to add. And my width we'll just call W. So we don't have to really do much manipulation here. We've got a lot of the information just from the directions. Now, it says the volume of the container is 336. Okay, so there's 2 ways to do this. The volume would just be length times width times height. So the W plus 9 times the W minus 4. All right, now 2 options for you. And you do whichever one you like better. I usually set this up as a system, and if you don't like that though, you don't have to. I'll show you 2 ways to do this. So this gives you the volume. It doesn't tell you we're going to maximize or minimize anything. It just tells you the volume is 336. What are the dimensions? Okay, so first way, you can actually set in the 336 for the volume. W plus 9, W minus 4. Now, the tricky part to this, and people will always forget to do this, but if you want to do it like this, what you have to do, if you want to use the graph to help you, you have to set this equal to 0. And you don't have to you don't have to multiply anything out, but you would type in, I'm going to replace these with x's real quick. So it'd be like x plus 9, x minus 4, and then you'd have to actually subtract the volume, and then on the graphing calculator or on Desmos, then you would find the zeros to answer this question. All right? So I would just graph one equation, and I would find the zeros. The other way you can do this is what I usually do, because I don't know, I'm just faster at typing it, I guess. I do a system. So I have my volume, which is that x plus 9, the x, and the x minus 4, and I want the volume to be 336. So if I just do y equals 336, that'll just be a horizontal line. If you want to do it this way, this is how I usually just do it. All you would do is find the intersection. So I'll show you both on Desmos real quick, but whatever's easier. That first method I wrote down, a lot of times people will forget to subtract the volume, and then they get the answer wrong. So I'm just telling you up front, that's not usually what I do, but if you do it that way, you can get the answer. So let me just run over to my Desmos real quick. So if you want to do the first way, like I said, you would type in your volume, that x plus 9, and then add an x, and then add an x minus 4, and then you'd have to subtract whatever they tell you the volume is, which is the 336. And you don't have to multiply anything out. I did not do something right because I do not have a graph. Oh, I do have a graph. I just didn't move it. Sorry. Manipulate this here. Okay, now, if I do it this way, you're going to find the zeros, and there's only one. and it's right at 7. And in that formula, x represented our width. So just as I'm doing this, I'm gonna record this real quick. So my width would be 7. And then I can figure out the other two, add 9 to it, the length would be 16, subtract 4, the height would be 3. All of these are in feet for this question. And the other way to do it is to do a system. And like I said, that's just kind of what I like to do. So I just graph whatever I wrote down for my volume formula, and then I write y equals 336. That was supposed to be the volume. And in that situation, you look for the intersection, which the x-coordinate there is still 7, just like I got for the other one, and then it tells you the volume would be the 336. So those are just two different ways to do it, whatever's easier for you. Is anybody having a question?